Here's the capture sheet that you should have in front of you so that you can take notes for this video. It's 2 pages, so it has a front and a back to it that looks like so. We're going to talk about atomic radius. Now, what is atomic radius? Atomic radius is just looking at atoms next to each other and saying which one is larger than the other. As you go across a period, you're going to notice that the atomic radius is going to start to decrease going across a period. And we'll talk about the reason why for that. But the basic trend for the atomic radius is that it decreases as it goes across a period. We say it follows the girdle theory, which girdles are what people wear to make themselves look thinner, and the more massive a person is, then the more the girdle has to be able to pull in. So there's going to be a certain point where you can't pull in anymore and you have to go to a bigger size. Well, the same thing goes for the atoms. As an atom gets more massive or adds protons to it, what happens is it pulls the electrons in further unto a point where it has 8 electrons, and then it goes to the next period. So from your notes, let's capture something. The atomic radius trend is that when you're going down a group, more shells are being added. And if more shells are being added, then you're going to add to the radius, or have a larger radius going down a group. The trend for atomic radius when I go across a period from left to right is that what we're doing going across a period is adding more protons. And if you're adding more protons, you're increasing the nuclear charge, the more positive charge. That more positive charge is pulling on the electrons to make the radius pull inward as well. Ionization energy. To define ionization energy, we say that it's the amount of energy needed to remove one electron from any atom. Using the example of a football player holding the football, let's use the football as our analogy for the electron. Here the football player is holding the electron, or the football, away from the nucleus. So you can see that the ionization energy is around 900 here. Notice the football is coming in closer to the nucleus, or the electron is closer to the nucleus here. And notice the ionization energy is getting higher. It's going to be harder to take that electron away from the nucleus. And then the football, or our electron, is being held tightly against the nucleus, and therefore the ionization energy has raised to 1681. So going across a period, the ionization energy is getting much larger. It's getting harder to take that electron away from the nucleus because the electrons are being held more tightly to the nucleus, as we saw in the atomic radius. On your note sheet, ionization energy trend then is that going down a group, electrons are held farther from the nucleus and are therefore easier to remove from the atom. So the ionization energy decreases going down a group. Going left to right across a period, electrons are held closer to the nucleus and are then harder to remove from the atom. And the ionization energy is going to definitely increase going across a period. Electronegativity is the measure of the ability to attract electrons from a different atom when those two atoms are bonded together. So let's take a look at this tug of war here, and let's pretend that the rope is our bond. So if I add more pull on one side, I'm going to add more attractive force for that bond, and it increases going across the period. Here's an illustration of electronegativity. Here we have an atom. Here we have an unpaired electron in its outer shell. Here we have another atom. These two atoms have now bonded in order to have a pair of electrons in their outer shell. Now this arrow, the blue arrow, is illustrating the electronegativity, or in other words, the attraction for that electron from the other atom in the bond. And let's compare electronegativities. Suppose I have a larger pair of atoms that are sharing electrons. Just like the best example here is if I go to the lower left of the periodic table, you're going to have larger radius, and therefore you're going to have the example that's on the right here. Remember, greater distance from the proton means that you're going to have less of that Coulombic attraction for that electron. So in this case, the example on the right shows that you have a lower electronegativity because the electron is much farther from the nucleus, and therefore it's going to have less of an attraction, even in the bond. So this example here is the lower electronegativity. Back to your notes. Electronegativity has a trend. When you go down a group, the electrons are held farther from the nucleus and have then a less of a Coulombic attraction for the protons there. So therefore, going down a group, the electronegativity decreases. Going left to right across a period, electrons are held by more protons in the nucleus and have a greater Coulombic attraction towards the nucleus. So therefore, the electronegativity going across a period, it's going to increase. Now all you have to do is just one question that's on your notes, and I'll be checking those in class tomorrow.